The old advice was simple: look for bad spelling and awkward grammar. That signal is fading. Generative AI can produce polished, natural messages in seconds. But phishing did not become magic. The attack still needs a false identity, a believable request, and a moment when someone clicks, downloads, signs in, shares a code, or sends money without independent verification. We will compare synthetic phishing messages in a local inbox lab, a traditional clumsy lure, a polished AI-style variant, and a legitimate business request. We will score grammar, identity, domain, link, urgency, and requested action. Then we will show why writing quality is weaker evidence now, while verified identity and safe business workflows remain decisive. The demonstration is entirely local. Every sender, organization, payment request, and message is fictional. Links use reserved example domains and never resolve to a login page. Attachments are represented by inert icons. We do not generate deployable lures, clone a real person, send email, harvest credentials, or connect to any external service. The first real change is production quality. A low-skill operator can create fluent grammar, a professional structure, and a plausible tone, then rewrite it repeatedly. FBI guidance specifically warns that AI can correct errors that once served as fraud indicators. A polished message is now almost neutral evidence. The second change is scalable personalization. Public profiles, conference pages, vendor announcements, and breached data can be summarized into role-specific context. The same campaign can produce variants for finance, recruiting, executives, or suppliers and translate them into natural local language. The core social engineering method is old. The cost per tailored message is lower. The third change is cross-channel reinforcement. A polished email can be followed by an AI-generated voice note, translated message, or synthetic image. The FBI has warned about voice and video cloning in impersonation and fraud. This makes a familiar voice or face insufficient proof of identity when the request is unusual or high impact. MITRE ATT and CK still describes phishing through familiar delivery paths, attachments, links, third-party services, and voice. The lure must reach someone and ask for an action, open a file, visit a site, reveal information, approve access, disclose a code, or change a payment. Those choke points are where layered controls can stop the attack. In the synthetic inbox, the AI-style message has perfect grammar and a helpful tone. A grammar-only rule marks it safe. The wider worksheet catches the mismatch. The display name and sending domain disagree. The reply path changes. The link destination is unrelated. The request is urgent, and the sender asks the recipient to bypass the normal payment process. The message quality improved. The trust evidence did not. Inspect the complete sender path, not just the friendly name. Use email authentication results, domain age and similarity, reply to changes, account history, and known communication patterns. SPF, DKM, and MARC are valuable, but not proof that a request is safe. A compromised legitimate account or attacker-controlled domain can authenticate successfully. Ask what changes if you comply. Does the message request credentials, a one-time code, a file download, remote software, an OAuth approval, sensitive data, a gift card, or a payment change? Does it discourage normal review? A beautiful sentence cannot make an abnormal high-impact action routine. Security systems should evaluate the actual destination, redirects, registration signals, file type, archive contents, and observed behavior. Use safe isolation or detonation for suspicious files and browsing. Rewrite or block risky links where appropriate. The user should not be the first component to discover where a button leads. For payments, account recovery, payroll, sensitive data, or access changes, verify through a channel obtained independently, not a phone number or link in the message. Require two-person approval and established change procedures. The FBI's business email compromise guidance has long emphasized direct verification for money transfers. AI makes that discipline more important, not obsolete. A user can be fooled by a perfect imitation. Authentication should resist that failure. NIST explains that phishing resistance prevents disclosure of valid authenticator outputs to an imposter without relying on user vigilance. Properly implemented WebAuthn and FIDO2 bind authentication to the verifier's domain. Protect enrollment and recovery with the same care. Reporting should be quick and non-punitive. Preserve the original message, headers, destination, attachment identifiers, and related events. Search for other recipients, block infrastructure, revoke sessions or tokens, reset exposed credentials, contact financial partners, and notify affected teams. Do not shame the reporter. Early reports are valuable detection signals. A training click rate is only one signal. Measure time to report, repeated exposure, blocked high-risk actions, time to contain, malicious infrastructure found through reports, phishing-resistant authentication coverage, and compliance with payment or access change verification. The goal is resilience when a convincing message inevitably reaches the inbox. This week, update 1 phishing checklist. Move spelling and tone to weak supporting signals. Put identity, sender path, destination, requested action, and independent verification first. Add phishing-resistant authentication to the roadmap and rehearse 1 high-impact transaction scenario. The complete worksheet and synthetic inbox diagram are on CipherVibe.